Did you know that a single button can generate over 1.5 billion different possible patterns? A simple button, often overlooked in our daily lives, holds a fascinating secret. For centuries, humans have been intrigued by the intricate patterns that emerge from the most mundane objects. From the intricate designs on a button to the majestic swirls of a galaxy, patterns have captivated our imagination. The button, in particular, has become a staple in modern life, found on everything from clothing to electronics. But what lies beneath its simple appearance? Let's dive into the world of button patterns. Imagine a universe where a single button can give rise to an endless variety of patterns. It's a concept that might seem too incredible to be true, but the science behind it is fascinating. The button's design is based on a mathematical principle known as the Fibonacci sequence. This sequence, discovered by the Italian mathematician Leonardo Fibonacci in the 13th century, is a series of numbers in which each number is the sum of the two preceding numbers. The sequence begins with 0 and 1, and then continues as 1, 1, 2, 3, 5, 8, 13, and so on. The button's patterns are generated by applying this sequence to a grid of squares, creating an intricate web of numbers and shapes.
But that's not the strangest part. The button's patterns also have real-world applications. In fields such as computer science and cryptography, the Fibonacci sequence has been used to create secure encryption algorithms.
The sequence has also been used in the design of buildings, where its golden ratio has been employed to create visually appealing and balanced structures. And then something unexpected happened. The button's patterns began to influence art and design. From the works of artists like M.C. Escher to the designs of fashion brands like Gucci, the button's patterns have inspired a new wave of creativity. The button's influence can be seen in the way designers use symmetry and asymmetry to create visually striking effects. But the button's patterns also have a darker side. They have been used to create optical illusions and tricks of the mind. Imagine a button that can make you see things that aren't there. It's a concept that might sound like science fiction, but it's based on real mathematics. The button's patterns have been used to create optical illusions that can make you see a 2D image as 3D. And then there's the phenomenon of the Mondrian effect, where the button's patterns create a sense of movement and energy. But what does this mean for us? The button's patterns have implications for our understanding of perception and cognition. By studying the button's patterns, we can gain insights into how our brains process information and create meaning. In the world of science, the button's patterns have been used to study the behavior of complex systems. The button's patterns have also been used in the design of video games, where they create immersive and engaging experiences. But that's not all. The button's patterns have also been used in the study of music and sound. The button's patterns have been used to create algorithms for generating musical melodies and rhythms. In the world of art, the button's patterns have been used to create stunning visual effects. From the intricate designs of fractals to the majestic swirls of a galaxy, the button's patterns have inspired a new wave of creativity. The button's influence can be seen in the way artists use symmetry and asymmetry to create visually striking effects. But the button's patterns also have a more practical side. They have been used to create efficient algorithms for solving complex problems. In the world of computer science, the button's patterns have been used to develop new encryption techniques and coding methods. And then there's the phenomenon of the Benoit-Mandelbrot effect, where the button's patterns create a sense of complexity and disorder. But what does this mean for us? The button's patterns have implications for our understanding of chaos theory and complex systems. By studying the button's patterns, we can gain insights into how complex systems behave and evolve over time. In conclusion, the button's patterns are a fascinating example of how mathematics can be used to create beauty and wonder. From the intricate designs of fractals to the majestic swirls of a galaxy, the button's patterns have inspired a new wave of creativity. So the next time you press a button, remember the intricate patterns that lie beneath its simple appearance. Subscribe for more fascinating stories about the intersection of mathematics and art. And let me know in the comments what fascinates you most about the button's patterns. If you found this fascinating, subscribe for more incredible stories like this.